Slice a pizza, and you've made a sector. Cut straight across with one chord, and you've made a segment. This whole chapter is just measuring those two shapes. And the secret is that both are simply a fraction of the full circle. Once you see that fraction, every area and arc length question becomes one quick substitution. Let's build it. Start with the sector, the region trapped between two radii and the arc joining them. The angle between those radii at the center is called theta. The smaller slice with angle theta is the minor sector. The bigger leftover piece with angle 360 minus theta is the major sector. Same circle, two slices. Here's the one idea behind everything. A full circle is really a sector of angle 360 degrees with area PIR squared. So a sector of angle theta is just the fraction theta over 360 of that whole circle. That gives the area of a sector, theta over 360 times pi r squared. Nothing to memorize beyond fraction of the whole. The arc, the curved edge of the slice, is the same fraction of the circle's circumference. Since the full circumference is 2 pr, the length of the arc is theta over 360 times 2 pi r. One thing to burn in, area uses r squared, but arc length uses just r. Mix those up and the whole answer is wrong. Two handy facts. The major sector's area is simply the whole circle minus the minor sector. PIR squared minus the slice you found. And memorize the easy fractions. A quadrant is 90 over 360, which is 1/4 of the circle. A semicircle is 1/2. A clock's minute hand sweeps 360 degrees in 60 minutes. That's 6 degrees every minute, a classic exam setup. Let's compute. A sector of radius 6 and angle 60 degrees, taking pi as 22 over 7. Area is theta over 360 times pi r squared. That's 60 over 360 times 22 over 7 times 36. 60 over 360 is 1/6, so we get 1/6 times 22 over 7 times 36, which is 132 over 7, about 18.9 square centimeters. Now an arc. Radius 21, angle 60, pi is 22 over 7. Arc is theta over 360 times 2 pi r. 1/6 times 2 times 22 over 7 times 21. 22 over 7 times 21 is 66. 2 times 66 is 132. 1/6 of that is 22 centimeters. Notice we used r, not r squared. So the sector is the clean slice. But what if you only want the little piece between a chord and the arc? The bit that looks like a thin sliver or a fat lens. That's a segment, and there's one neat trick to find it. Picture the minor segment. It's the sector with the triangle cut away, the triangle formed by the two radii and the chord. So the rule is beautifully simple. Area of a segment equals area of the sector minus area of that triangle. Sector minus triangle. Always that order, never the reverse. How big is the triangle? With the center O and central angle theta, the triangle's area is 1/2 r squared sine theta. Two special angles make it effortless. A chord that subtends 60 degrees gives an equilateral triangle, and a chord that subtends 90 degrees gives a right isosceles triangle with area 1/2 r squared. And remember, the perpendicular from the center to a chord always bisects that chord. Let's do the classic. A chord of a circle of radius 10 subtends a right angle at the center. Find the minor segment with pi as 3.14. Sector first, 90 over 360 times 3/1400ths times 100. That's 1/4 of 314, equal to 78.5. Triangle, 1/2 r squared, 1/2 of 100 equal to 50. Segment is 78.5 minus 50, 28.5 square centimeters. And the major segment is just the whole circle minus that minor segment. The full circle is PIR squared, 3.14 times 100, 314. So the major segment is 314 minus 28.5, 285.5 square centimeters. A chord always splits a circle into exactly these two pieces. Step back and see how small the toolkit really is. Sector area, fraction times pi r squared. Arc length, fraction times 2 PIR. Segment, sector minus triangle. Major piece, whole circle minus the minor piece. 4 lines run the entire chapter. Your turn. The question's on screen. Pause if you like, but try it first. 10 seconds. Go. Area of a sector is theta over 360 times PR squared. That's 90 over 360, a quarter times pi times 14 squared. With pi as 22 over 7, a quarter times 22 over 7 times 196, that's 154 square centimeters, option B. Lock it in. Everything is a fraction of the whole circle. Sector area uses pi r squared, arc length uses 2 pi-r, and a segment is just the sector with its triangle removed. Last challenge, it's on the screen. Don't say it aloud, type your answer in the comments, and I'll pin the right one. And that's areas related to circles, sectors, arcs, and segments, all from one simple fraction. Free notes with 60 practice questions are in the description. Subscribe for the next chapter. This is Clarix. Keep going.